Hello class, welcome to a quick lesson about soil itself. Soil is really just the thin crust of weathered rock on top of our planet. So if this is our globe, soil is just this tiny bit above the mantle. It can range in depth from a couple millimeters to hundreds of feet depending on your location on the Earth. Soil is really just a classification of different particle sizes. So anything less than or equal to 2 millimeters in size is technically soil. Soil further breaks down into 3 different categories: sand, silt, and clay. Sand is the largest. You see it on the beach. All these things you can see with your naked eye, anything from 2 millimeters down to 0.05 millimeters. Silt, some of it you still can see with your eye. A lot of it starts to get very small, 0.05 to 0.002 millimeters. And then clay is most assuredly microscopic. It's anything smaller than 0.002 millimeters in width. As I alluded to with the soil crust on the Earth, soil depth differing from place to place, soils themselves can differ from place to place as well. So here on a beach or in the sand dunes of a desert, we have obviously just a whole bunch of sand. There's no real connection between these particles. These are all loose and can be blown in the wind, easily erode. You can even see some particulate being blown around in the back here. This is clay. It's the things that you can make ceramics with. It's what really provides soil its very sticky nature. As we'll see in later lessons, clay brings a lot of beneficial properties to soil, especially in relation to agriculture. So this is hardly any soil at all. Remember, soil is less than 2 millimeters in size. A bunch of this is just rocks, right? Most of this up high on the mountains. We maybe have a thin bit of soil developing below the moss and lichen that are covering these rocks. Maybe a little bit of soil kind of hiding in the crevices of most of these rocks. But what's really happening here, again, differing from place to place, the soil that could be here really is ending up down here in a river delta or somewhere else low in the valley. So all the fine soil particles, all these bits are being transported by water and wind and various other methods into something like this, where we see a bunch of fine particles suspended in the water. Now, of course, humans have lived in all of these environments, and we've been practicing agriculture for around 23,000 years. But much of our understanding of agriculture and our soil knowledge has not survived transcription into the written and digital age. In 1883, a Russian scientist by the name of Vasily Vasilyevich Dokuchev published works suggesting that soil could be classified depending upon certain soil-forming factors. In essence, Dokuchev's claim was that a soil underneath various conditions would be distinctly different from another soil. So a grassland soil would be different than a tundra or evergreen forest versus, a nice prairie oak savanna, say. So we would have distinct soils, A, B, C, and it was not one homogeneous entity around the globe. In 1941, Hans Jenny, a Swiss scientist, took Dokuchev's idea of soil orders and modernized his soil-forming factors into an acronym called Clort. All right, say it with me. Clort. All right, this stood for climate, organisms, relief, parent material, and time. So climate deals with things like precipitation and temperature. Let's maybe make this a bit more clear. Organisms had a lot to do with explaining some of this soil order that we saw back with Dokuchev. So for example, here we have maybe a pasture where there's just a bunch of grass. And as the grass grows taller, the roots, of course, grow longer and deeper. Another part of this organism factor is, of course, animals. So if grazing animals came in and mowed down a lot of this grass up top, then, of course, the plant sloughs off roots in order to regain some energy to put up some top growth to gain photosynthesis again. So animals chew off the top, and then, of course, the roots abscise as well. So now we've got stubby grass, little roots. Eventually, grass grows again, roots grow again, animals come in, eat it again, roots chop off again. What's happening over time is an injection of carbon. And so, well, and many other things, a lot of biological activity as well. But basically, there's a lot of things happening with these plant roots and, of course, the organisms coming to eat that affects the climate, affects the soil, and thus that's why organisms are part of Clort. All right, R for relief. This isn't really used anymore. It still fits into the acronym, but we now would call this something like topography. And this has to do with elevational change. And so just like we saw in the introduction with rocks on top of a mountain and particulate landing in the river delta, this is what relief tries to capture about soil formation factors. So we've got mountains here, boulders are falling off and falling down, rains falling, climate, right? Rains falling and eroding and making more particulate come down, and this is all carried by river, and slowly sediment is deposited as the river trails along and gravity pulls solids out of suspension. All right, parent material. So just like we were talking about this, so sedimentation is happening, right? Remember some of your basic geology? As a river is flowing, let me see if I have a blue marker here. As the river, well, can you tell the difference? Not really. So as the river's flowing, it's widening, it's slowing down, probably. I mean, when you consider a flat land prairie versus on top of a mountain, this water's moving very quickly compared to this water. And so eventually, depending upon the size and thus the weight of the different soil particles, soil being eroded from the mountains are being laid down as sediment along the river. And then over time, more sediment. And so as the river's flowing and particles are being deposited, we're getting the formation of sedimentary rock, which, if you remember from your basic geology course, is one of three basic types of rock: sedimentary, metamorphic, and igneous. And so what parent material is talking about is referring to where on Earth the soil that you're dealing with has developed. And so depending on where you are, if you have volcanoes, that are spewing a bunch of lava, and you're getting an island that has a bunch of igneous rock, then that's going to be much different from a place that has developed a bunch of sedimentary rock that's just eroded from mountains over a long period of time, which brings us to our last section. Time, T, Clort. Time is the last part. It's hard to visualize. Basically, it's all these other parameters taking place over time, because a raindrop doesn't just exist and cause change. Rain happens over time. Erosion, the change in topography occurs over time. The difference between a volcanic island and a river flat is the difference of like millions and millions of years. And so these are all the soil forming factors: climate, organisms, relief, parent material, time, Clort. Okay, that wraps it up for this lesson about soil itself. We have Clort. We have the history of agriculture for about 23,000 years. We have the history of soil science itself for about 60 years. And this really has been a whirlwind tour, and I encourage you to take a full soil science class.